In 4.2, we are continuing our work with triangles, and today we are going to focus on proving that triangles are congruent. So, in this section, you will be matching up corresponding parts of congruent triangles. You must pay attention to the order for the names of the triangle. So, for example, in my first example that I have here, I have triangle ABC is congruent to triangle DEF. In order for these two triangles to be congruent, all of my corresponding angles and all of my corresponding sides are congruent. So if I wanted to match up my corresponding angles, again, order matters. Sometimes when they rotate it, it could be kind of hard to figure out the corresponding parts, so I can just look at the way my triangle is named. So angle A here is going to correspond with my first angle mentioned here. And we can see angle A and angle D are congruent. My next angle is angle B. It is going to be congruent and correspond with angle E. So angle B and angle E are congruent. And then lastly, we have angle C, which will be congruent with angle F. So our third angle. Now we can also match up our corresponding sides. So again, look at our order. Side AB is going to be congruent to side DE. Side BC is going to be congruent to side EF. And then our last side, AC, is going to be congruent to side DF. So all of my corresponding angles and all of my corresponding sides are congruent. And we are paying attention to the order in which the triangle is named. In this example, it is telling us that these two quadrilaterals are congruent. Quadrilateral DEFG is congruent to quadrilateral SPQR. Our task is to find the values of X and Y. So in order to solve problems like this, we're going to use the concept of corresponding angles are congruent and corresponding sides are congruent. So again, this one we can see our figures have been rotated so they don't look exactly the same. So we need to pay attention to the order. I see here that I have 6y plus x. I can't really solve something that has two variables right now, so I'm going to look at this 2x minus 4. And I know that 2x minus 4 has to be the same length as something else. So if I pay attention to my order, RQ, or QR here, last two letters, should correspond with FG. If I look at FG, it has a measure of 12. So I know that those two lengths have to be the same. So 2x minus 4 equals 12. I have 2x. I add 4 to both sides equals 16. X equals 8. So now that I know x, I can go ahead and plug it in here. So instead of having 6y plus x, I'm going to have 6y plus 8 equals, and now I need to again identify the corresponding angle. So we're dealing with angle Q here. So angle Q, if I pay attention to the way that it's named, should correspond with angle F. I look here, angle F is 68 degrees. So 6y plus 8 equals 68. I continue on, I subtract 8, so I get 6y equals 60, y equals 10. We have one new theorem in this section called the third angles theorem, and it seems like it's kind of an obvious statement when we read it. It says if two angles of one triangle are congruent to two angles of another triangle, then the third angles also have to be congruent. Basically, we know that our triangles all have 180 degrees in them, so if two angles are the same, by default, that third angle has to be the same. So if I look here at this picture, it's asking us to find the measure of BDC. So I'm going to get a different color. So BDC, this is the overall angle that we are trying to find. So I can see my two triangles that I have here are triangle ACD and triangle ACD and triangle BDC. So if I look, I can see this angle is 45 degrees Angle A and angle B should be congruent, so that's also 45 degrees. Angle D, the smaller angle here in triangle ACD, is 30 degrees. This angle is also 30 degrees. So now when I look at this triangle here, I have determined one angle is 45, one angle is 30. To figure out my remaining angle, all I need to do is use my triangle sum. So I know there's 180 total degrees, so I subtract 45, I subtract 30. I get that my missing angle is 105 degrees. Our last example from section 4.2 is a proof. We are trying to prove that triangles ACD is congruent to triangle CAB. So far, the only way that we know how to prove two figures are congruent is we have to show that every single angle and every single side is congruent. So if I look here at my figure, I have already marked my given information. We know that AD is congruent to CB. We know that DC is congruent to BA. We know that angle ACD is congruent to angle CAB, and angle CAD is congruent to angle ACB. So now when I'm looking at my proof, I have all of my statements, and we just need to fill in our reasons. So our number one reason is always given whenever we do proofs. But if we notice, it only mentioned our congruent sides, which was only half of our given information. We also were given that two pairs of angles were congruent. So if I quickly look at my statements, I can see it's down here at statement number 3. So I'm going to fill in that that's given as well before I start. So now I see in step 2, I have AC is congruent to AC. So if I look at my diagram here, I see that these two triangles are sharing the exact same side. So obviously if it's the same side, it has to be congruent. In my reason, I'm setting something congruent to itself. So if we recall from chapter 2, whenever we set something congruent or equal to itself, that was our reflexive property. So now we have all three sides are congruent. And now for reason number 4, we said angle B is congruent to angle D. And why were we able to say that? Well, we knew two pairs of angles were congruent, so the third one has to be, and that was our theorem that we just learned, the third angles theorem. So now we have proven that every single angle and every single side is congruent, so our triangles are congruent. So for now, our final reason is going to be definition of congruent triangles. So this should help you out with the proof problem that you have in your homework for section 4.2.